Hi, this is Stephen Brower from Renton Valley Community College. This is an addendum to Chapter 9 on array processing. And I want to show this demo first and talk about what this demo does, and then we'll see some array support that's built into the processor itself. So this already was built. So imagine if we have two arrays, one starting off with this set of values. Now this is an array of signed D words, the other array being empty. And the idea is that we'll take this, for each element in the array, we load it into memory, multiply it by 10, and store it to the other array. So the other array, as you can see, is a multiple of 10 of the values that are there, and is showing it as handling the signed as well. So up to this point, prior to Chapter 9, the way that we would do that is, so if I look at this as being our loop, within the loop, we're loading from one array, doing the multiply, and storing to the other array. So ESI is loaded with the address of the source array, and that's the 8675309, and then EDI is loaded with the address of the destination array. That's the one that's going to have the 80, the 60, etc., etc. The multiplier here is a variable. Well, it's the value 10, so that's where the multiply is taking place. Now, remember what this does. This assumes EAX has one value, which we're loading here. The result is going to be the upper 32 bits in EDX, the lower 32 bits in EAX, and this is not doing an error check. This is just assuming everything's fine, and then just taking the values and then sticking them in. So before the bottom of the loop, it is moving both ESI and EDI to the next set of elements. I just realized in this demo I got ESI to EDI. What's the difference? Sorry, my comments did not match the actual statements. But ESI, since ESI is the source, go to the next element in source. EDI is the destination going to the next element. And remember the loop statement subtracts 1 from ECX. If ECX is greater than 0, it's going to go to top loop. So again, prior to Chapter 9, this is what we've seen that we can use for basically doing this operation of taking data from one array, multiplying it, and storing it into the other array. So what we're showing here is that multiplication. Oh, and by the way, let me come back here. If I make EDI array 1, then what it's doing is it's storing back to the same array. So array 1 initially was 8675309. Well, I'm ignoring the signs. And then we're storing it back to the same place. So in this case, we have ESI and EDI as being both the source and the destination. We just put it back to the way it was before. Okay. So processor support. So there are two commands that can help with this, and there are certain assumptions that these commands take on. So one of them is that instead of loading from ESI into EAX, we actually can do an LODSD. And when we do that, we don't have to advance ESI. It'll do that automatically. Then we can do an STOSD, which will store the value, and my indenting is going off, sorry. And by doing that, it will automatically advance the EDI as well. So for the loop that we have here, this is assuming that ESI has the array that we're doing the source from. This assumes EDI is the destination. It's automatically will advance the ESI and the EDI for us. All we have to do is make sure we set a direction. And so I have this commented off screen, but the CLD is going as a way of setting the direction to make sure we're going ascending as opposed to going descending. So with these changes, We get the same results, and it's just that the LODSD, so it automatically is loading EAX. It assumes that EAX is what you want loaded, because that's what's used a lot for processing. It assumes that we're loading from ESI, so we're loading from the array that's here. STOSD, this is storing what's in EAX to, well, the array that's being referenced in EDI. Each one of these is advancing ESI or EDI, so that's why we don't have to manually advance it. That advance takes place automatically. So it's these are array support, array processing commands that are built into the processor. So this is not a KIP, thanks KIP for a lot of things. This is not a KIP Irvine thing. This is an Intel thing. So it's built into the processor. If we wanted to store back to the same place, we can just make EDI, the destination, the same. And this way it's writing back to the same place. So this way we can, by doing that, store back to the same array that we had. We just put it back to 2 again. And so that it is going to the second array. So for things like, I'm gonna butcher this. This example might not be. I butchered the example so much that I'm not going to say it. I'll just say that these commands were added to the processor to help with manipulating arrays. It's good enough. I'm tired.